Hi students, I think all of you are fine and good. So, in my bridge course classes, I have started with indices, logarithms. That means first I have taught indices and next I have taught logarithms. So, I think you have seen my videos of indices and logarithm. They are the very basic terms. Now, in this class, again I am going to solve some of the basic terms with their definitions. Clear? So in this class, let us see polynomials and let us try to write the polynomials of higher powers very easily. Clear? So let us see what is the technique to write the polynomials of the higher powers very easily. Clear? For example, you can write a plus b whole square, a plus b whole cube, a plus b whole to the power of 4, a plus b whole to the power of 5, so on. Suppose a plus b whole to the power of n, then how to write it? Let us see that. Clear? So now, before going to polynomial, first we must understand what is monomial. Monomial means the term of the type 4x. This is called monomial. Or you can write x square. This is also monomial. Clear? Or you can write xy. This is also monomial with two variables. No problem. This is also monomial. So monomial means that is you are going to have a single term of x or single term of xy. Clear? Next, if you go for binomial, there you are going to write two terms of the type a plus b, or you may write x plus y, or you may write 2x plus 1. Clear? These are called binomials. That means here there are two terms, that's why they are called binomial. Here there are only single terms, that's why they are called monomial. Clear? Next, let us go for this type of n elements. Here there are two, here there are two, here there are two. That's why it's called binomial. Now let us write n elements. Clear? That means it is going to be the polynomial. So first let us understand polynomial. Polynomial means an equation or a function with n terms are called your polynomial. That means polynomial is a function in the form of p of x. Polynomial is a function in the form of p of x that is written as a naught plus a1x plus a2x square plus a3x cube plus so on to an x to the power of n. Clear? So here there are n terms, that's why it is called polynomial in variable x. That's why it is called polynomial in variable x, because it contains n different elements. It contains two different elements, that's called binomial. It contains one term, that's why it is called monomial. Clear? So monomial, binomial and polynomial. Polynomial means polynomial is a function in the form of p of x equal to a naught plus a1x plus a2x square plus a3x cube plus so on to an x to the power of n. Here I am restricting you, this a must to be real numbers. I am restricting you for this a for only your real numbers. Clear? That means I am restricting this polynomial only for real number set, because in real number plane only we are going to study for 11th and 12th standard of these polynomials. Whenever we enter into the complex numbers, I will tell it different way. Clear? So but now we are studying it in the real plane. That's why I am telling you I will restrict my a to real numbers. Clear? So a belongs to real numbers and that n belongs to your non-zero integers, or what we can say it as positive integers. Clear? So n belongs to positive integers, a belongs to real number. Clear? So from these two, I define my polynomial, that is p of x equal to a0 plus a1x plus a2x square plus a3x cube plus so on to an x to the power of n. Clear, students? So this is what the definition of polynomial says. Polynomial is a function in the form of a0 plus a1x plus a2x square plus a3x cube plus so on to an x to the power of n, where the small a0, a1, a2, a3 so on to an are your real numbers, and this 0, 1, 2, 3, that is nothing but n value must be your positive integers. Clear? Positive integers including 0, positive integers union 0. Clear? So that means 0, 1, 2, 3, 4, 5, 6, 7, 8 so on towards n. Clear? So a belongs to real numbers, n belongs to positive integers union with 0. Clear? Okay. So this is what the definition of polynomial. Now let us see how to write the expansion of some of these polynomials. For example, see here, you can write a plus b whole to the power of 0. What is a plus b whole to the power of 0? A plus b whole to the power of 0 will be 1. Clear, students? So a plus b whole to the power of 1 will be what? It will be a plus b. Clear? Now a plus b whole square will be what? It will be a square plus 2ab plus b square. Clear, students? Now what will be a plus b whole cube? See how I will write? A cube plus 3a square b plus 3ab square plus b cube. Clear? That means there must be some rule to write these expansions. I can write a plus b whole to the power of 4 also. See how I will write? A to the power of 4. Clear? Next, 4 times of a cube b. Clear? Next, 6 times of a to the power of square b square. Next, 4ab cube. Next, plus b to the power of 4. So see how can I write the expansion of a plus b whole to the power of 4. There must be some technique which I am using. If I am writing so easily, means there must be some technique, or it must be wrong. In this two there will be one thing. Clear? So for that let us see what technique I am using to write this expansions. Clear? So for that, see what I am using here. 1, I will write 1, 1. Clear? 1 plus 1 is 2. I will write here 1. I will write here 1. 1 plus 2 is 3. 2 plus 1 is 3. Here and here I will write it as 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. I will write at the end 1. Again see. Same, last term is 1. 1 plus 4 is 5. 6 plus 4 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And last term is again 1. This is what we call it as Pascal's triangle. This is what we call it as Pascal's triangle. See, I can write a plus b whole to the power of 5 also. How I will write? Please say it. A plus b whole to the power of 5. That is, first term a to the power of 5. Next term 5 a to the power of 4 into b. Next term 10 a to the power of 3 b square. Clear? Next 10 a to the power of 2 b to the power of 3 plus, next I am going to write 5 a b to the power of 4, and last term will be b to the power of 5. See how I am writing so easily. First term is 1, second term is 5, third term is 10, fourth term is 10, fifth term is 5, and last term is 1. That means I am using my Pascal's triangle method to write these expansions. That is very fine. Are you getting my point? So that technique you must understand. Clear? So if you understand that technique, it is going to be very easy to write the expansion of any terms. Clear? So this is how you have to write. Pascal's triangle means how to construct Pascal's triangle. Let us see here. How to construct Pascal's triangle? First, I will take the expansion of a plus b whole to the power of n. A plus b whole to the power of n. Here what is n term? 0. Whenever you have n term, you have 1. So at n equal to 0, I will write 1. Clear? Next, at n equal to 1, see here, at n equal to 1, you have 1 and 1. So I will write 1 and 1. Clear? At n equal to 2, see this expansion, at n equal to 2, last two terms are 1, middle term is 2. Last two terms are 1, middle term is 2. At n equal to 3, see this, last two terms are 1, that means last two terms are 1, middle two terms are 3, that is 3 and 3. Clear? So now if I go for n equal to 4, last terms will be 1, here 3 plus 1 will be 4, 3 plus 3 will be 6, 3 plus 1 will be 4. This is how you have to build your Pascal's triangle. First 1. Next step, again 1 and 1. Last two places are 1. See, 1 plus 1 is 2. Last two places are 1. 2 plus 1 is 3. 2 plus 1 is 3. Last two terms are same again, 1 and 1. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Last two terms are 1. Clear? So this is how I have to construct my Pascal's triangle. So now let us go for n equal to 5. See, last terms will be what? 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. That terms are going to be here. Clear? So this is how you have to identify coefficients. This is nothing but what? Coefficients of your expansion a plus b whole to the power of 5. This is one technique to find coefficients. Clear? Okay. See, you must write coefficients also. You must write coefficients also, and you must write AB and their powers also for any expansion. See, here a square b, ab square, b cube. Here a cube. Clear? Here what you are going to get? A to the power of 4. 1 less a to the power of 3. Here there is no b. That means b to the power of 0. B to the power of 0 is 1. That's why I have not written here. Here b to the power of 1. That means the power of b is increasing. Power of a is decreasing. Are you getting my point? Power of a is decreasing. Power of b is increasing. Clear? Okay. Next, this will be 6 by Pascal's triangle. Again, a to the power of 3 to a square. A square to a, it will decrease. See the b terms. Here b to the power of 0, b to the power of 1, b to the power of 2, b to the power of 3. That means the power of a is decreasing, the power of a is increasing. That is what the technique of writing a polynomial of any power. Clear? Okay. So let us take one example and solve so that it will be very easy to you. Okay. So now, simple example I will take. That is only already I have written a plus b whole to the power of 5. Clear? So let us make some more place to write. A plus b whole to the power of 5. How to write this? First, you understood the Pascal's triangle. First coefficient is what? 1. 1, I will not write it. A to the power of 5, b to the power of 0. Here coefficient will be 1. Next coefficient is what? 5. 5a to the power of 4. I have to decrease my a power and I have increased my b power. 5a to the power of 4 into b. Next, see this coefficient is 10. 10 a to the power of 3 b square. I am decreasing my power of a. I am increasing my power of b. Next, 10 a to the power of 2 b to the power of 3. Next, 5 a to the power of 1 b to the power of 4. Last one is 1 b to the power of 5. Here a power will be 0, that is 1. Coefficient is also 1 multiplied with b to the power of 5. So what you got, that is a to the power of 5, 5 into a to the power of 4b, 10 into a to the power of 3 b to the power of 2, 10 into a square b cube, 5ab to the power of 4 plus b to the power of 5. This is how you have to write a plus b whole to the power of 5. I think this method is very simple to you. Clear? So now you got a plus b whole to the power of 5. No problem. So now you can write the expansion of any polynomial with any power. You can write a plus b whole to the power of 6 also. A plus b whole to the power of 6 also. But students, please remember, whenever I go on increasing this to 20, suppose let us consider, if you go for n equal to 20, then here you have to write 20 Pascal's triangle whenever n equal to 20. That means you have to construct Pascal's triangle which is equal to how much? 20. That means n equal to 20. See, if n equal to 5, I have to write this much. Are you getting my point? Then what about n equal to 20? How much I have to write this? Clear? So for that reason, what I will do, I will remove this Pascal's triangle. I will remove this Pascal's triangle and I will tell you one simple formula. Please you remember that. That is NCR equal to n factorial divided by r factorial into n minus r factorial. If you remember this formula, it can be used to write your coefficients. For this, see here coefficient is how much? 1. So I will write it as n term is 5. 5C0 because it is 0th term. Clear? 5C0 a to the power of 5 b to the power of 0. Clear? So 5C0, if you calculate, see 5 factorial divided by 0 factorial, 5 minus 0 factorial is 5 factorial, cancel it, it will get 1. So you will get 1 here, no problem. Plus 5C1 a to the power of 4 b to the power of 1. If you calculate 5C1, you are going to get 5. See here, 5 factorial, 1 factorial, 5 minus 1 is 4 factorial, cancel the terms, you will get 5. Clear? So like that, 5C2 a to the power of 3 b square, 5C3 a to the power of 2 b to the power of 3 plus 5C4 a to the power of 1 b to the power of 4 plus 5C5 a to the power of 0 b to the power of 5. So these are the coefficients. See, 5C0 is 1, 5C1 is 5, 5C2 is 10, 5C3 is 10, 5C4 is 5, 5C5 is 1. Clear? So this is how you have to write if this term goes very big, 20, 30, 40 like that. Clear? So if you go for here, suppose here it is minus, means alternatively you have to change the signs. Here if it is plus, no problem. You have to write all the terms as plus. First I will discuss this plus and next let us go for minus. A plus b whole to the power of 5. So these terms you are going to get. Clear? As you all know, every time there cannot be plus, it can be minus also. If it is minus, what you have to do? Alternatively, you have to change the sign. Plus, here it will be minus, here it will be minus, here it will be minus. Clear? So alternatively, you have to go on changing the signs. Suppose now a plus b whole to the power of 20. How you are going to write? Same. 5C0 a to the power of 20 b to the power of 0. You must start with 0. plus 5c1 a to the power of 19, you have to decrease b to the power of 1. Next, plus 5c2 a to the power of 18 b to the power of 2. Like this you have to increase a power, you have to decrease a power, you have to increase b power, you have to continue it for plus how much? This is, sorry, not this is 5, this is 20 c0, 20 c1, this is 20 c2, because n value is 20. Last term will be what? 20 c20 a to the power of 0 b to the power of 20. The last term will be 20 c20 a to the power of 0 b to the power of 20. So this is how you have to expand a plus b whole to the power of 20. Suppose here you have minus plus, this will be minus, plus next term will be minus, plus alternative term minus, plus alternative term minus. Clear? So like that, plus minus has to be changing in alternative manner. Clear? Like this you have to write your any expansions to the power of n. Clear, students? So please remember this formula. Please remember this formula to write the coefficients. Please remember this formula to write the coefficients. To write a and b, please remember one term, nth term for a, bth term start with 0. You go on decreasing a power, you go on increasing b power. So it will be very easy to write your expansions. So every time you can't need to by heart, or you don't need to by heart any formula of the type a plus b whole cube. Now see how can easily we write a plus b whole cube. Every time you don't need to be perfect with the formulas. Just you can write it as first term. What? A cube. That is 3c0 is 1. Next 3c1 will be 3. 3c1 will be 3. A square b. Next 3c2 will be again 3. A b square. Clear? Last term will be 3c3, that is 1, and a to the power of 0 b to the power of 3. So see how easily I can write my a plus b whole cube. Clear, students? So this is how you have to be perfect of this technique of writing the expansion of binomial. The expansion of binomial with any power. If here it is minus, plus, minus, plus, minus, you go on changing. Clear? So that will be the expansion of your binomial terms. Clear, students? I think you are perfect of writing the expansion of binomial with any power. So make sure that by writing some examples, take some examples, that is a plus b whole to the power of 19, a minus b whole to the power of 19. Do this homework by writing the expansions. A plus b whole to the power of 13, a minus b whole to the power of 13. Clear? A plus b whole to the power of 7, a minus b whole to the power of 7. You take these examples as a homework and try to write the expansions. Clear? Okay. So let us meet in the next class. If you have any doubts, please WhatsApp that particular questions to my number so that I can clarify your doubts through WhatsApp. Clear? So if you have any doubts, please WhatsApp me those things. Okay.